Hello everyone, welcome to Ekeeda platform, and this is Jangid here, your electrical faculty. And in this video, I'm going to talk about the detection of the line faults. How we can detect the line faults which are occurring in the systems. Now we will talk one by one. Okay, so let's talk about that. The normal converter control is not sufficient for clearing the fault. Okay, that is not sufficient for clearing the fault as the deionization of the line by driving the rectifier into the inverter mode requires the special control action which is initiated on the detecting the line faults. Okay, so it is already specifying that whatever the normal operation of normal operational control which we were using for detecting our fault conditions, so that is not sufficient if we are using that, because that de-energization of the line will happen, and that is by the driving of the rectifier into the inverter mode. And while doing this, we actually require the special control actions which is initiated on detecting the line faults. Now we are, as we have talked about the detection. Okay, so that detection of the line faults is based on one of the following conditions. And what are these following conditions? Okay, let's talk about them, the first and second. So what is the first actually saying? That the sudden drop in the DC voltage measured on the line side of the reactor. So if there is a sudden drop in the DC voltage, okay, and that is on the line reactor, that should be measured on the line side of that. Now second is saying the simple thing, that is the sustained low direct voltage that is already persisting there. The sustained low direct voltage there, if the voltage value, DC voltage value is low and it is continue to operate, continue to be in that level or low value, that is called the sustained low direct voltage. Now we will talk about mathematical operations related to that. Mathematically, these two conditions can be expressed as follows. So I have written for you that is actually the Vd is less than K1, dVd upon dt is less than minus A for the duration tau is greater than tau1. Similarly, the second mathematical relation is specifying that the Vd is less than K2, Vd is less than K2 for the duration of tau is greater than tau2, and whatever the constants which I have written for you, that are simply the basic constants, or you can say that the positive parameters, that is the K1, K2 and capital A, and that are chosen along the tau1 and the tau2. These are the time constants. Now the criteria for selecting these parameters, what parameters? These parameters, you can say the K1, K2 and the tau. Okay, so these three important parameters should be there. The first is your selectivity, to ensure that the protection operates rapidly for the DC line faults, not for the AC faults converter. The selectivity is kind of that the protection, the whatever the protection which are going to be operated for, it should be in rapid for the DC faults. Whenever the DC fault is operating, it should be detected, it should be sensed, it should be reliable. Okay, so that should be detected in if there are so many faults. If there is a fault for the DC line, that should be selected for that, not for the faults in the converter in the faults, not for the AC faults converter faults. Now the smoothing reactors, these smoothing reactors prevents the rate of voltage drop. Okay, the rate of voltage drop in the line exceeding a limit of AC and the converter faults. So that is going to be prevented by that. Now second is the sensitivity, the small value, a small change in the value that should be detected, that is called the sensitivity. The sensitivity, it is saying that the DC line protection must operate satisfactorily for the normal values, okay, the arc resistance, this puts an upper limit of A. So whenever we are talking about the sensitivity, okay, so I have already told you that the small change in the value that should be detected, the DC line protection, it should be must operate satisfactorily. Okay, whatever we are actually required, that should be operate for that. And for the normal values of the arc resistance, and that put the upper limit of A. That is actually the upper limit of a value of A. Now, reliability. If we are talking about the reliability, the uh, protection must operate reliably, obviously. Okay, it should be a system, any system for the transmission, it should be a reliable for all the DC line faults. So that is a false, including the false, okay, sorry, including the faults through a high, that's we are actually providing the voltage level limit. So there is, we are providing for the voltage level limit. Now, the constants k1 and tau1, okay, which we have discussed in the two mathematical relations, the k1 and tau1 are actually chosen such that the protection does not operate for the healthy pole, only for the faulted pole. So the value is decided in such way that it should be only considered for the faulty sections only, not for the healthy sections. If you can limit the fault current at those or at the faulty sections, that at the faulty section, then fault current or fault voltage will not obviously be transmitted to the healthy sections, and the healthy sections will be remained in the normal operating conditions. Now, in the bipolar DC lines, it is an essential because the power can be transmitted at the sufficient levels even after the monopolar ground fault. So whenever you are having the monopolar ground fault, and if we are using the bipolar DC lines, then the power can be transmitted at the sufficient level. So I hope you have understood all the concepts, all the points which I have discussed for this lecture. Thank you so much.